Hello viewers, welcome to my channel. For today we want to continue with polynomial. We've started the tutorial on the topic polynomial. So in this edition we are going to treat the remainder theorem of a polynomial. So if you are new, consider to subscribe to the channel for more of my videos, like and share. So suppose that the function p of x, which is a polynomial, is divided by k, which is a linear function, x minus c, where the c could stand for any constant. Then the quotient, the answer we are going to get, the q of x, and the remainder is what? R. The quotient will be this, and the remainder will be r. That is a remainder after you divide. We explain under division that if the divisor is not a factor of the dividend, definitely you will get what? A remainder. So that simply means that the function is going to be equivalent to the product of the divisor and the quotient plus that of the remainder. In a layman perspective, if I have 7 is equivalent to, let's say, 3 times 2 plus 1, where this 3 is our divisor and this 2 is our quotient and 1 is the remainder. Simply put, the function is going to be 7 divided by 3 equals to 2 plus 1 over what? 3. This is the fraction remaining. So if you are doing any division by polynomial and your denominator is not a factor of the numerator, you are bound to get a remainder. Now, this remainder theorem only works for linear function denominators. So it will be x plus 1, x minus 2, 2x plus 1 linear. The moment this becomes 2, we are not going to continue that division. So if that is the case, let's suppose that when we substitute this x to be the same as what? C. Simply put, finding the zeros of this linear function. If you are to find the zeros of that function, it will be x minus c equals to 0. The whole of this is 0. Therefore, when you send the negative c to cross, it becomes x equals to what? C. That's what I mean. That suppose we want to put x to be equal to c, then it's going to be p of c, which is the constant, will not be equivalent to k c as x minus c quotient of c plus what? R. And we know c minus c will give us what? 0. 0 times quotient will still be 0. And that will mean that p of c will be equals to what? R. So simply put, if you are asked to find the remainder of any polynomial by a linear function, you can find the zeros of that linear function and put the value into your polynomial, and that will give you a remainder. For example, if I have p of x to be equals to x to the power 3, 3x minus 5, and I am asked to find the remainder of this, if it is what? Divided by x minus what? 2. Let me make it x plus 2. If we are to divide this by this, we want to find what? The remainder. What will be the remainder if this function is divided by this? As we can see, this is a linear function. So I can go ahead and say that the p of c equals my remainder. Therefore, first of all, find the zeros of x plus 2 equals to 0. That implies that your x is going to be negative what? 2. So therefore, my remainder is going to be p of negative 2, p of c equals to whatever I see x. We know x is to the power 3. But the x we are seeing here is the one we are seeing in the equation. X, x, x. So when the x now change to negative 2, this will also change to negative 2 all to the power 3. here will be plus 3 into bracket x negative 2. Then your minus 5 will come. We are trying to find a remainder. So this is going to be, since this is an odd number, we are going to get negative 2 exponent 3 will be 8. We know if you multiply this, we are going to have negative 6 minus what? 5. All the way here will give us negative 11. So we are going to have negative 19. Therefore, the remainder is what? Negative 19 if this function is divided by this. Remember, it is always a linear function as our divisor. Okay. Now, this is one way of getting it. Another way is using the division. You see, they say what? Suppose the function is divided by this. We know division, long division, using what? The long division approach. So we are going to have our x plus 2. Then we have what? X to the power 3 plus, this is x to the power 1. There is a term missing. So I introduce that term as 0x to the power 2 before my 3x will come minus 5. Polynomials have a power of decreasing orders of x from the left to the right. So 3, 2, 1, 0. So now our division continues. This will divide here by saying that x to the power 3 divided by x. This will have minus 1. So I have x squared. When it multiplies back, it gives you x to the power 3. 2 times x squared plus 2x squared. Now let's subtract. X cubed, 0. 0 minus 2x squared will give us negative 2x squared. Bring down the next term. This becomes your new dividend. X will go into this, power of 2, power of 1. The power decreases to what? 1. So minus 2x. Let it come and multiply back your x to give you negative 2x squared. Negative 2 times 2. Negative 4x. So our subtraction, minus 2 minus minus 2, that will be plus. So 0. 3 minus what? 4 will give us positive 7. So 7x. Then this is going to be minus 5. Can we divide this by this? I believe the powers are the same. So it goes there to cancel this, leaving only what? 7. So plus 7. 7 will multiply this, will give you 7x. 7 times this, I believe it will be 14. So we have what? Plus 14. So now let's subtract. This minus this, 7, 7, 0. Minus 5 minus 14. Minus what? 19. So therefore, our remainder will be what? Minus 19, as we did for finding the zeros of that linear function. So you can see the two approach. We can find the remainder by equating the linear divisor equals to 0. That is, finding the zeros of that linear function. Or we can perform our long division and get the last number as our remainder. I believe you get the concept. So any approach you want to pick, don't forget it is always a linear function. The moment this is not linear, then the wording of the questions will change. Thank you for watching. Subscribe if you are new, like and share, and leave a comment for us to get interactive. Bye-bye.